Okay, we're going to connect F and F prime and F double prime again. This is a review lesson that sometimes I don't assign it, sometimes I don't lecture it. But since you're going to take a quiz today, the second part of the period, it's not a bad idea to go over a few things here. I won't do the whole thing, but we'll see what I can cram into 45 minutes. We're looking at a graph, and this is how it always starts out on the AP. They give you a picture. You never know what it is. You're looking at it, and he's defined it as the graph of F. So by looking at F, he wants you to try to make some connections to F prime and F double prime. And feel free to be creative what you think is going on. What can I say about F prime by looking at this graph? Well, I can say the first thing I always think about is what about increasing and decreasing? Uh, I can talk about max and mins. I can talk about what do the max and mins mean regarding either F prime, or F double prime. But since we're looking at the graph of F, I know that it's increasing from here, infinity negative, all the way to that relative maximum. I also know it picks back up at increasing. So that would imply the slope is positive. So what I'm going to write is, I know that f prime of x is greater than 0 from negative infinity to a negative 4, and pick back up at the negative 2 all the way to the 1. And because I'm going to say f is, well, f is increasing. That means the slope is positive, which is exactly what this actually says. Okay. What else? That's one thing. I don't know how many we're going to get out of it. Let's see. I get bored. How about the decreasing part? Let's do the decreasing. I can tell you that conclusions about f prime of x is less than 0 from, and that intervals are going to be where f is decreasing, because it's decreasing with a negative slope, so it makes sense that I would say that f prime of x is less than 0. That would be the negative 4 to the negative 2, and then pick back up union from the 1 all the way to infinity. Because f, and why am I saying f? Because I'm only looking at f, so I should put it in terms of why do I know this is true about f prime if all I'm looking at is f? Because f is decreasing. What else can I say about f prime? Well, f prime, if I had the graph of f prime, it would have some zeros, wouldn't it? It would have some zeros. F prime, let me put that black and black. F prime has zeros at x equals to negative 4, negative 2, and a 1. Why? Because if you look at it, right here is where the slope is 0. So that means your derivative is 0, because you'd have a tangent line that looks like that. So that slope of the tangent line is your first derivative, equal to 0 at each of those places. So the derivative has a zeros at those places because they are relative extremas of f. You can also talk about, well, we already did the greater than 0, less than 0. What else can I say about the first derivative? What if I look at, what kind of function would f prime be? What do you think? F prime of x would be a, well, f prime of x is what? It's got 1, 2, 3 turns, opens down forever. It's a quartic. Shouldn't say would be, it really is. It's a quartic. It's a quartic. Because we're looking, wait, that's not f prime, that's f. Let's back it up one step. F prime of x is not a quartic. F is a quartic. F would be like this. F could be similar to x to the fourth. So what would f prime be if you do the derivative of a fourth degree? It would be a cubic, because f of x is a quartic. What else could I say? Some other stuff might come to my mind, but I think I highlighted the max and mins. Or did I? No, I didn't. Well, yeah, I hired extremas. I just haven't defined those extremas, as being maxes or mins. Do you think you could do that? Let's try it. Let's just see if we can. 5. F prime has a relative max at x equals to, if I'm only looking at this as a quartic, the function, and I want to visualize the cubic. First of all, would the cubic look like that? Good question, right? Relative max. Relative max occurred. Let's see here. You know, by looking at the picture, there's probably a point of inflection about here. And there's got to be another one here. I wrote on the picture. See, concave down, concave up, right up. Where would that other one be? It has to change again. Concave up. Probably somewhere in here, where the point of inflections are. So, since this point of inflection, the concavity went from up to down, that's going to be f prime has a relative max. So let me put that down here into the box. What was I asking? Relative max at x equals, I'm going to put out equals, I don't know, approximately a negative 1/2. Because I know for a fact that concavity changes. Concavity changes from concave up to concave down, which also implies f prime of x changes from positive to negative. Now, the opposite of that is also true then. F prime of x has a relative min at x equals to something. I'll look for that in a minute. That would be because f prime would have a relative minimum. Let's see, where would that be at? It's the other point of inflection. It's right here. This is where f prime has a relative min, because f was concave down, right here, concave down, and then it switches to concave up. Also, since the concavity changed, you know the second derivative changed at that point. So I'm going to say x equals to a -3 because f prime of x, no, not because, that means f prime has a relative min, and we know that f double prime of x, which we're not even, should be up at the top. I think we're talking about, that part is actually describing f double prime when it changes from, what did I say? It was concave. It was concave down to concave up, right? Concave down. That would be, let's just do it. It was concave down means the second derivative was negative to positive. Enough of that. So conclusion about f double prime of x. I guess I should say what I just said. There is a point. Well, f has a point of inflection. So let's not talk about f now. Let's talk about f double prime. F double prime changes signs at x equals to -3, and x is approximately -1/2 because concavity changed signs. Let's be a little more detailed. X equals -3 went from concave down to concave up. X equals approximately -1/2 concave up to concave down. That means the point of inflections, I can say f, number 2 here, that's actually a lot there, f double prime has relative extremas where f double prime of x was equal to 0. That's not extremas, those are zeros. The zeros occurred, well, at the point of inflections, has extremas at points of inflections. Again, the derivative is 0 at x is 3, and x is negative 1 half, negative 3, negative 1 half. All right, we shot that up a lot. Let's try to get another problem in. This graph is a graph of f prime. So I'm looking at f prime, and I'm going to talk about conclusions about f. Okay, well, the first thing we learned a long time ago was f must be increasing from, now please don't start here and go all the way up to here. That's would be what we would say if it was f, but it's not f, it's the derivative. It's increasing only when it's positive, when the first derivative is above the x-axis. So we know f is increasing from negative 2 to the 1 union 3 to infinity. F is increasing because f prime is greater than 0 in both of those places that I circled. We know f is decreasing from, decreasing would occur here and here. F is decreasing from negative infinity to the negative 2 union 1 to 3, because f prime is less than 0 in those intervals. What else can I say? We're talking about f from the picture of the derivative. So the third thing, let's see, does f have a relative max somewhere? Where would relative max occurs? That would be where the function changes from positive to negative. So from positive to negative, left to right, does not happen here. That's negative to positive, because it jumped the axis there. This is positive to negative. This is negative to positive. So it only occurs there at x is 1. At x equals to 1, because f prime changed from positive to negative. How about f must have a relative min? I think there's two of them, where relative min means it changed from negative to positive, below the axis to above the axis. All right, now let's talk about what can we tell about the second derivative. Okay, looking at the first derivative again, let me clear off all this gobbledygook. That's the first derivative. Going to describe the second derivative. Now, I'm going to treat it as a function and its derivative, just as if it was a normal function and the normal derivative. Since this is f prime to second derivative, it's the same observations we're going to make. We can literally say that f double prime is greater than 0 from the interval. Now that would be where the derivative of the derivative is positive. So this is a derivative, and the slope everywhere is positive as I go up here till I get to this number here. Negative as I go till I get to here. Positive again as I go. So greater than 0 would have been from negative infinity to the maximum of that first derivative, which was at x equals to a negative 1, union, jumping all the way over here to x is 2, the slope is positive again to infinity. I can tell you that would be my first thing I noticed. The second thing I noticed is that the second derivative is less than 0 on that third interval where the derivative of the derivative is negative because it's decreasing. So that's from the negative 1 to the positive 3. Because and I should have put my becauses here. Why is it greater than 0? Well, because f prime is increasing because f prime is decreasing. What else can I tell about the second derivative? We use second derivative all the time to talk about points of inflection. That's always where the second derivative is equal to 0. And I think I circled them. The first derivative has an extrema here. That means the second derivative is equal to 0. The first derivative has an extrema here. So at those places, I can actually tell you that a third point, f double prime, is equal to 0 at x equals to the negative 1 and x equals to a positive 3 because they are the extremas of the first derivative. And I just look closer at my graph. That's x is 2. Did I use 2? Increasing from negative infinity to the negative 1. Yeah, 2 to infinity. So I should have put a 2 right here. Okay. And I think that's enough that we can describe. That's what I did really want to talk about because it closes the gap here. Here is a picture of the second derivative, and we're going to talk about the function from that and the first derivative. Okay. Let's see what we can talk about this one. We're looking at the second derivative. And let's just, before I even write anything, what do these values mean for the second derivative? What do they mean about the function? That's where your second derivative is equal to 0. So right there, I have something I can say about the function. The function has, first thing I can say is f of x has points of inflection at, now, one of those are a point of inflection. One is not. They're different. This one is where concavity of the function changed from concave down to concave up. This one is not really a point of inflection because it was concave up and it's still concave up. So all I can really address is that x equals to 0. Point of inflection, so I better take off the s. It's just 1 point of inflection at x is 0 because f double prime changed signs. All right, what else can we say? Obviously, this was not an inflection point. It was a possible point of inflection until you make a sign chart and realize it's not. Okay. This place, what does it mean if your second derivative has a maximum? Well, what does that imply? Looks to me like the derivative of this changes signs, but does that mean anything? The derivative of the derivative of the derivative? Well, it would if we were talking about the jerk. The jerk is the third derivative, but we're not talking about the jerk. So the derivative of the derivative of the derivative doesn't mean anything. The third derivative doesn't mean anything for us right now. So where it changes signs have very little meaning. What does it mean about this region down here? Well, it's related to what I just wrote, but it's worth mentioning. F is concave down from negative infinity until we get to that 0, because the second derivative is less than 0. And then I can talk about the two intervals that are concave up. And we have to break it into two because at this particular location, the derivative is not positive, nor is it negative. So we'll use both of those. Okay, so 3, f is concave up from 0 to 3. Couldn't see it. Union 3 to infinity, because f double prime is greater than 0. I have to put that here, greater than 0. Anything else? I got where it's increasing, where it's decreasing, where it's 0. I'll take a breather on that. I don't know if I can say a whole lot more. Well, I think I could talk about one more thing. I could have said this on the other problem too. What am I looking at? It's a second derivative, right? And it's a cubic. It's a cubic second derivative. What would the function have been in order to get to be a cubic after two iterations of derivatives? wouldn't it have started to be something like an x to the 5th power? Then you do the derivative and you get 5x to the 4th power. Then you do the second derivative and you get 20x to the 3rd. Yeah, f was a quintic. F is a quintic, or 5th degree polynomial. Let's talk about the derivative. So what we need to picture is that if we're talking about f prime, picture this to be a function. And then we are looking at the picture of its derivative right here. So all the things I'm going to say would be very similar to what does the picture of a derivative mean about a function. Let me try to clean that up so I can have your full attention. If that's a picture of a derivative, and it truly is, that's the picture of a derivative, what does it mean about the function that represented? Well, obviously, this area down here means the derivative is negative. That would imply that the function of that derivative is decreasing from negative infinity to x is 0. Then we can say the function, which is f prime, is increasing from, that's up there. Be careful. I know you're tempted to say from 0 to infinity, but that would be wrong. It's 0 to 3, union 3 to infinity. And the reason up here was because f double prime was less than 0. Because f double prime is greater than 0. Which is why I had to break that up into two different pieces here. Why I unioned it. What does it mean? If your derivative goes from negative to positive, what would it mean about this value here, where the derivative changes signs? I think you got it. There is a relative. I'm going to say f prime has a relative extrema. What kind of extrema? If it went from less than 0 to greater than 0, less than 0 to greater than 0. It's a max or min. A minimum at x is 0 because f double prime went from less than 0 to greater than 0. What's happening at this place where the derivative went from greater than 0 to greater than 0? Nothing. It was a critical number. What else can I say? What else can I say? I can say number 4. I can say that the first derivative is concave up from negative infinity to negative, where is it at? No, to positive 1. To, not negative, positive 1. Union, is there another concave up? Yes, from 3 to infinity. So I got all of this, and all of this, because union 3 to infinity, because f prime, double prime of x, is increasing. And I can say the graph of the derivative is concave down on the interval. That would be the leftover. That would be from 1 to 3. Concave down because the second derivative is decreasing. What was that interval going to be? Negative 1 to 3, because the second derivative is decreasing. I can also say one more thing before I leave. Let me clean this junk up again. The extrema of the second derivative is, that is a point of inflection of the derivative graph. On the derivative graph, which happens at 1. F prime has a point of inflection at x equals to 1 because it is the extrema of f double prime. More importantly, I would say that it is the extrema of f double prime, which implies that the third derivative of x is equal to 0. The jerk. I didn't think I was going to talk about the jerk. I just did. So the third derivative would be 0. The third derivative, I didn't even pay attention to this one. The third derivative would be 0 there as well. I have to extend that. Now that my brain juices are flowing, I say 7f has a point of inflection at x is 3 because f triple prime of x changes directions. In other words, it was negative, became 0, then became positive. Same thing here, but that was different. That did that. All right. 3 quality problems. And of course, if I keep looking, there's definitely more questions we could be answering. But I'm running out of time. And there are definitely a homework assignment that's related to this. This will be extra credit. Extra credit. Day 38. It would be good to prepare for your exam. And there is some free responses. I think I gave you 2 of them. The packet, I didn't give you all of them. There's too many. And there's still more questions that you could play with, but I didn't give them to you. There's too much. I can't give you everything. It's just too much work. So anyway, bye.